Okay, in this video, we're going to take another look at a three-phase unbalanced Y-connected load. We know this load is unbalanced because we need to have two things to have a balanced load. The two things are, we need the same impedance or current in each phase, and we need the same power factor in each phase. And we don't have either of those things in this load, so this is definitely an unbalanced load, and there will be some neutral current. And what we want to do with this load is find the current in the neutral. And to do that, we are going to have to start by finding the current in each phase. We have a 480 volt supply. We want to find the current in each phase. Stop the video at this point and determine the currents in each phase and do a phasor diagram that shows the phase voltages and the phase currents for this load. In order to figure out the current in each phase, we need to know the phase voltage, and this 480 volt supply is the line voltage. In order to figure out the phase voltage, we just need to take 480 volts divided by root 3, V phase equals V line divided by root 3, and our phase voltage will be 277 volts. If 277 volts is the voltage across each phase, that voltage divided by the phase impedance will give us the current in each phase. I equals E over Z. Once we've done that calculation, we should find that phase current IA to N, 277 volts divided by 20 ohms, will give us a current of 13.85 amps. And because this current is a leading current, we would draw it, the phase voltage is VAN at 0 degrees. We would draw this current 0.9 lead, inverse cos of 0.9 should give us 25 degrees. We need to draw the current 25 degrees ahead, 25.84 degrees ahead of the voltage for that phase, because current leads voltage in that phase. In phase B, 277 volts divided by 10 ohms gives us 27.7 amps. At a 0.8 lag, inverse cos 0.8 gives us an angle of 36.87 degrees. So for phase B, the voltage for phase B is at 240 degrees. And the current for phase B will lag the voltage by 36.87 degrees. So 240 minus 36.87, 203.13 degrees is where phase B current is at on our phasor diagram. Phase C current, 277 volts divided by 30 ohms will give me 9.23 amps. That is the current in phase C. And it is at a 0.7 lag, inverse cos 0.7 gives me an angle of 45.57 degrees. Voltage for phase C is 277 volts at 120 degrees. That minus 45.57 degrees gives me the current at 74.43 degrees. So this is what the phasor diagram should look like for the three phase voltages and the three phase currents that we have. Once we have this plotted on our phasor diagram, we can now calculate our neutral current. To calculate our neutral current, we'd simply take the horizontal and vertical components of our three phase currents to figure out the horizontal and vertical parts of the current that is the neutral current in the circuit. So I simply take, for phase current A, 13.85 amps at 25.84 degrees, 13.85 times the cosine of 25.84 degrees gives me the horizontal part of that circuit. 13.85, the sine of this angle will give me the vertical part of that current. So we just take cosine for horizontal, sine for vertical to break each of these currents into a horizontal and vertical part. For current B, cosine of 203 degrees times 27.7 amps gives me that for horizontal. The sine of 203.13 degrees times 27.7 amps gives me that for a vertical. Phase C, the cosine of 74 degrees times 9.23 amps gives me the horizontal part of that current. The sine of 74.43 degrees times the current of that phase will give me the horizontal part of that current. Once I've broken each phase current into its horizontal part and its vertical part, I simply add the horizontal values up and the vertical values up, keeping in mind that a negative is a current in the opposite direction and it opposes current in the positive direction. So I add my positives up, subtract the negative. Whatever the bigger number is, subtract a smaller number. In this case, the total horizontal is going to be minus 10.53. For the vertical, the positive vertical is going to be the bigger part. So the 8.89 plus 6.037 minus 10.88 will give me the vertical side of 4.048. I now have the two sides that make up the triangle to determine my neutral current. I basically just show those two sides. My horizontal, minus 10.53, my vertical, 4.048. Use Pythagoras' theorem to calculate my neutral current. And hopefully this practice again helps you to understand how these kind of questions work. We will almost never have to plot where this neutral current is, so it isn't really important to know where it's at.